The next form we graphed in was y equals ax squared plus bx plus c. So this is new because we have a bx term in the middle. When that happens, we know that our vertex is no longer on the y-axis, it's moved left or right. But we have to do a little bit of work to figure out exactly how far left or right it has moved. So when we're wanting to graph this, the first thing we want to do is to find the axis of symmetry. And in this case, we need to use the formula x equals negative b over 2a. So we look at our equation, and b is the coefficient for x, and a is the coefficient for x squared. So for this problem, our b is negative 4. So negative 4, that means that's going to be positive 4, over 2 times a, and a from our equation is 2. So 4 divided by 4 is 1. So our axis of symmetry is x equals 1. Don't forget on that axis of symmetry, you need the x equals. Now to find the vertex, once we have the axis of symmetry, we can plug the vertex in, or x, into our original equation. We had 2x squared minus 4x minus 4. And so in place of x here and here, we're going to substitute the 1 that we got. So y equals 2 times 1 squared minus 4 times 1 minus 4. Remember, you do exponents before you multiply, so 1 squared is 1 times 2 is 2 minus 4 minus 4. So 2 minus 4 is negative 2 minus 4 is negative 6. So the y value of the vertex is negative 6. So our vertex for this parabola is at 1 comma negative 6. So I'm going to plot that, 1 comma negative 6. I'm going to draw my axis of symmetry there. And then I look at the shape. A is 2. So we've graphed several like this. We know that from 1, 1, 2, 4, 3, 9, we multiply these ups by 2. So we get 2, 8, and 18. So from our vertex, we're going to go over 1 and up 2, and then over 2 and up 8. Let's see, where's that? Right here. And we get this nice narrow parabola because it's a vertical stretch by a factor of 2. Here we have another one, still in the form ax squared plus bx plus c. So we know that for these we have to find the axis of symmetry first by doing x equals negative b over 2a. Our b is 2, so negative 2 over 2 times a is negative 1/2, so negative 1/2. We get negative 2 divided by 2 times negative 1/2 is negative 1. So we get x equals 1. I'm sorry, x equals 2. And now we know the axis of symmetry is x equals 2. So we're going to plug that into the original equation. Everywhere we see an x. So y equals negative 1/2 times 2 squared plus 2 times 2 plus 1. Square your number first. 2 squared is 4. Half of 4 is 2. So we get negative 2 plus 2 times 2 is 4 plus 1. So y equals 3. So our vertex is the ordered pair 2 comma 3. So over 2 and up 3. Since a is negative, we know that it opens down. It's a vertical shrink by a factor of 1/2. We're going to multiply all of our vertical movements by 1/2. So we're going to go over 1 and down 1/2. Over 2 and down 2, over 3 and down 4.5. Be sure as you're watching, the scale for all of these that we've done on our graphs has been 1 on the x and 1 on the y, but be sure you watch that carefully because it can change. So just look carefully. The next form that we learn to graph with is vertex form. Vertex form looks very much like the form that we used for absolute value graphs. We still have that h and k, and we learned that h and k are what give us our vertex. So the vertex for these is always going to be h, comma, k, and since the axis of symmetry goes through the vertex, it's always going to be in the form x equals h. So h gives us our left and right translations, and k gives us our up and down translations. A still does the very same thing. It's still our vertical shrink or stretch. So if we look at this first one, we have x minus 1 minus 4. So h is positive 1 and k is negative 4. So that's our vertex, 1, negative 4. And our axis of symmetry is x equals 1 because that's the x value. So we're going to go over 1 and down 4 for our vertex, and then we've got our axis of symmetry right through the middle of that. This one has a vertical stretch by a factor of 2, so we're going to go over 1 and up 2, and over 2 and up 8, just like in the last graph that we did. When we do y equals negative a half times x plus 2 squared plus 1. Now, because this is a plus 2 and the formula says minus h, our h was actually a negative 2 and our k is positive 1. So negative 2, positive 1 puts our vertex right here. And our axis of symmetry is x equals negative 2, right there through the vertex. Now our shape is negative a half, like it's been on several of these, so we know it's going to open down, and instead of going over 1 and down 1, we're only going to go down half as far as we normally do. Instead of going over 2 and down 4, we're going to go down 2, because that's half of what we normally do. And then over 3 and down 4 and a half. We'll draw our curve. Now we haven't been talking about domain and range for these, but we certainly can. The domain for this second graph is all reals because it's still a quadratic function. The range, what we see for this one, we have a highest point up here at the vertex, and it goes down from there. So this is where y is 1. So the range is all y values less than or equal to that value of 1. If we want to look at increasing and decreasing, on the left-hand side, as we read from left to right, our value is increasing, and then on the right-hand side, it is decreasing. So it's increasing for all of the x's that are left of the vertex. Well, that means all the x's that are less than negative 2. So it's increasing where x is less than negative 2. And it's decreasing for all of the x's that are greater than 2. On our first graph, we can see that it's decreasing until we get to where x is 1. So it's decreasing for x's that are less than 1. And then it's increasing on the other half. So it's increasing for all the x's that are greater than 1. You'll notice for all of these that that line of symmetry is what's going to divide them. Right, the last form that we learned to graph using was factored form. And the nice thing about factored form is that it gives us our x-intercepts. If our equation is already in factored form, then to find the x-intercepts, we just substitute a 0 for y. And we look at the equation and we say, what value of x is going to make x plus 4 be 0? Well, that would mean it would need to be negative 4. So negative 4 comma 0 is one of our x-intercepts. What value for x in the second one makes it equal 0? Well, that one's positive 2. So our other x-intercept is positive 2, 0. So we're going to fill that in down here, negative 4 comma 0 and 2 comma 0. And we'll plot them on our graph here and here. Now, when we're looking at our graph and we want to know the axis of symmetry, it's got to be right in the middle of those two because we know that the axis of symmetry goes through the middle of the parabola. So I can see that x equals -1 is going to be my axis of symmetry. Now, if I can't tell if the numbers are too big or they've got decimals or it's just a little difficult, then all I need to do is average my two x-intercepts. -4 plus 2 divided by 2 is going to give me -2 divided by 2, which is -1, and that's where my axis of symmetry is. Now, when I'm ready to find my vertex, I do like I did when it was ax squared plus bx plus c, and I take my axis of symmetry from right here, and I plug it into the original equation to find the value for y. So I'm going to say y equals 2 times my axis of symmetry is -1, so -1 plus 4 times -1 minus 2, and I'm going to simplify. So y equals -18. So my vertex is at -1, comma, -18. So over 1 and down 18, you'll see we changed the scale for this one to make it graph a little nicer. Now we've got 2 other points on our graph already, but if I want, since I know that it has a vertical stretch by a factor of 2, I can add a couple of points by going over 1 and up 2, and then over 2. Yikes, I was telling you all to pay attention to the scale and then I just left it off. So you'll notice that the y's go up by 2's, but the x's only go up by 1's. So when I go over 1 and up 2, it's actually right here and here. When I go over 2 and up 8, it's 2, 4, 6, 8. My points are right here and right here. So there's my shape. Right there. On the second one, it's also already factored for us, but you'll notice the form looks a little bit different because we don't have 2 sets of parentheses, but that's okay. What can I plug in for x right here that's going to make y equal 0? Well, -1/2 times 0 would make it equal 0, so 0, 0 is one of our ordered pairs, and then what makes x plus 6 equal 0? That's going to be -6. So there's my 2 x-intercepts, 0, 0, and -6, 0. Oops, we need to fix this graph a little bit. Okay, 0, 0, and -6, 0. Right in the middle is going to be -3, so our axis of symmetry is going to be right here at -3. So let's fill in what we know. Down here, 0, 0, and -6, 0. Axis of symmetry at x equals 0. Now to find the vertex, sorry, not at x equals 0. X equals -30. Lots of zeros in there. So now we're going to plug in the -3 into the original equation. So -1/2 times -3 and -3 plus 6. So we get +3/2 plus 3. So this is 1.5 plus 3. So that's 4.5. So we're going to go over 3 and up. Whoops, we need to go up 4.5. So let's move our graph one more time. Let's see. Down here a little bit. Let's see, we're done with that. We can move these back to where they go. All right, so up 4.5. And we've got 3 points, but another one might be better. So we have -1/2, so we're going to go over 1 and down 1/2, over 2 and down 2. And there we've got our nice shape. Right there. And that's how we graph using each of the different types. You can always do domain and range, increasing and decreasing for any of these types. You just want to look, especially for increasing and decreasing, where is your graph increasing? For this one, that's where x's are less than -3. Where is it decreasing? For this one, that's for all the x's that are greater than -3.